Welcome to Engineering Python. This is a Python programming course for engineers. In this video, I will talk about the basic numeric data types. Different types of data are stored in a computer in different ways. The data type determines what values a variable can have and what operations can be performed on it in a program. There are two basic numeric data types in Python. Int variables store integer numbers such as -5, 0, and 3. Each of these is a whole number and doesn't have a decimal point. Float variables store floating point numbers such as 0.25, 0.0, 3 point, and -0.5. Each of these numbers has a decimal point. The fractional number parts can be omitted sometimes. Inside a computer, int and float variables are represented quite differently. We can use the type function to tell the data type. -5 is an integer number, 0 is an integer number, and 3 is an integer number too. They don't have a decimal point. 0.25 is a float number, 0.0 is a float number, 3 point is a float number. We give -0.5 to variable x and test the type of x. It's also a float number. They all have a decimal point. Why do we need two numerical data types? There are several reasons. First, integer numbers can represent counts of real-world objects. For example, you may have 1 or 2 cats, but not 1.5 cats. Second, most mathematical operations are more efficient when dealing with integer numbers. Third, the int data type is an accurate representation of a whole number, while the float data type stores only an approximation of the real number. For example, Python cannot differentiate 0.1 and 0.1501. Let's try this. When we type in 0.1 and run this cell, the result is just 0.1. When we type in this number, the result is still 0.1. When we compare this number and 0.1, we find it's not greater than 0.1. The result is false. That's why we say the float data type is just an approximation and not an accurate number. In general, operations on integer numbers produce integer numbers. Operations on float numbers produce float numbers. Operations on both integer and float numbers produce float numbers. 1 plus 2 equals 3. They are all integers. 1.0 minus 2.0 equals -1.0. They are all float numbers. 1.0 times 2 equals 2.0. The first one is a float and the second one is an integer, and the result is a float. The division operator is kind of special. It always returns a float number. The result of 7 divided by 3 is 2.333. This is the same as 7.0 divided by 3.0. Note that we are supposed to get a 3 at the last digit. However, we get 5. This is the closest value Python can get to represent the infinite looping decimal number. Again, the float number is just an approximation. We can use the format function to return the formatted string that is rounded to certain decimal places. For example, x is 23.45741. We only want to see 2 digits after the decimal point. We can use a format function with 2 arguments. The first one is x, the second one is a format string. The 2f means 2 digits after the decimal point. The rounded result is 23.46. Note that the format function just returns the formatted string. It doesn't change the original number, so x is still 23.45741. We will talk more about string formatting in another video. In addition to the simple math operations like plus, minus, times, and divided by, Python has provided some other operators. We already know that a single slash means division. So the result of 5 divided by 3 is 1.666. Double slashes mean floor division. It cuts off the part after the decimal point. So the result of 5/3 is 1. The result of 5.0/3.0 is 1.0. The percent sign is a modulus operator in Python. It returns the division remainder. For example, 5 can be divided by 3 one time with a remainder of 2. So the result of this statement is just 2. Double stars are used for exponentiation. 2.0 to the power of 3 is 8.0. Exponentiation has higher precedence than multiplications and divisions. So we will calculate 2 to the power of 3 in this statement, or 2 cubed, which is 8. And then we do the multiplication. 5 times 8 is 40. The ABS function will return the absolute value of the parameter. In this case, the absolute value of negative 3.5 is just 3.5. Python numerical data types also support the following compact operators. Let x be 1, 1 plus equals 2 will update x value by adding a number 2 to itself. The result is 3. Let x be 1.0. X minus equals 2.0 will update x by subtracting a number 2.0 from itself. The result is negative 1.0. Let x be 1.0, x star equals 2 will update x by multiplying itself by a number 2. The result is 2.0. Let x be 7, x slash equals 3 will update x by dividing itself by a number 3. The result is 2.333. Let x be 5, x percent equals 3.0 will update x by performing modulus on itself. The result is 2.0. We can explicitly convert between these two numerical data types. 5/3, we will get the integer modulus 1. Then we use a float function to convert the integer to a float number 1.0. In this case, we use the int function to convert 3.9 to an integer. Note that the int function will just cut off the fraction parts. If you want to round the float number to the nearest integer, you should use the round function like this. The result is 4. 5 will be rounded up and 4 will be rounded down. So 3.5 will be rounded up to 4 and 3.4 will be rounded down to 3. Sometimes it's convenient to use the thousands separator, comma, to display large numbers. For example, it would be nice to display 1,234,567.89 like this. However, you should be careful about this. If you directly assign this to a variable x, we will see the result is actually a pair of parentheses enclosing three numbers 1, 2, 3, 4, and 567.89. This is a tuple, which will be discussed in more detail in another video. The right way to do this is to use a string format method. Assign this large number to x, then format x. Before that, there is a dot, and before that, we have a string. This string contains a pair of curly braces. Inside the braces, we have a colon mark followed by a comma, which is a thousands separator. We will discuss the format function in more details in another video. When we print y, it's in the correct format. This is exactly what we wanted. Because we use the percent sign as a modulus operator to calculate the division remainder, we cannot use it to show the percentage like this. The error shows this is invalid syntax. We do know that 64% is just 0.64. We give it to x and then use the format function to add a percent sign like this. A colon followed by a percent sign. This is output. It has too many zeros. Let's just keep one digit after the decimal point. We put .1 before the percent sign. Great, now we have 64.0%, which is exactly what we wanted. Okay, that was about the basic numerical data types. The course materials are available on YouTube and GitHub. You can watch the course videos in sequence. If you like this video, please subscribe and share. I'm Wang. Thanks for watching.